the last 2-3 days I was just talking to you through the Google Meet, and I was sharing some notes related to the first topic, sets. I thought that today I have some summary of the whole sets chapter and sent you the video links. I just give a brief and quick summary of the chapters and sets, its definition. And already it is known to you, set is the collection of well-defined objects. Collection of well-defined objects. The underlining is well-defined. What is meant by is well-defined? I have already made it clear is that suppose if you talk about the collection of a renowned mathematician, collection of renowned mathematicians, then collection of renowned mathematician, when we say that renowned mathematician, that term is not defined. For me, renowned mathematician so and so X and Y may be there. For other people it may be some different things. So that renowned is not well defined, so we cannot call it as a set. The same way the collection of a good painter or good artist. So what is the criteria for deciding the good is not known to us, not well defined. So such things will not come as a set. But the remaining things normally in mathematics, set of integers, set of a natural number, etc., etc., it will come to the set. And that is about the definition of the set. And the other thing is that the representation of set. There are two ways of representing the set. One is roster form. Here, all the elements of the sets will be put in the flower brackets. List out in the flower brackets. So 1, 2, 3, 4, etc. So when you list out all the elements in a flower bracket, that formation is called the roster form. And the second one is the set builder form. There are two ways of representing the set. One is roster form, other one is set builder form. In the set builder form, we represent the set by a variable, and its a common property will be for the elements of the set, and that common property will be explained. Say x is equal to set of all x, such that x is equal to 2n plus 1, where n is a natural number. Then it is called a set builder form. So what is actually set of all x such that x is equal to 2n plus 4? What are the elements will come? We can write this into this roster form also. When n is a natural number, so the first natural number is 1. So 2 into 1, 2 plus 1, 3. Second one is 2 into 2, 4 plus 1, 5. 2 into 3, 6 plus 1, 7, it goes like that. So when you represent the set by denoting a variable x, and the common property of that will be mentioned, that is called the set builder form. And you already learned how to convert a set into roster form to set builder form, and set builder form to roster form. I have given one example last times like this. And when I have gone through your assignment, I could see that most of you could not do it correctly. Suppose if I want to represent this set, this is now in the roster form. I want to represent this set into a set builder form. So it will be like this: set of all x such that x is a perfect square. Most of you have written only up to here, perfect square. Perfect square number less than or equal to 100 is also required. Equal to 100. Or you can write in another way: set of all x such that x is equal to n square. And where n is between 10 and 1. So n is from 1 to 10. When you take, you will get this one. When n is equal to 1, you will get this one. N equal to 2, you will get this. N equal to So that is the converting into set filter form as well as the roster form. So that is the representation of the set. Then different types of sets also we have written. That is this is 1, 2 representation. Then types of sets. Third, what we have explained. So what is null set? Null set means a set which does not have any element. Say, I write like this. No elements. Sometimes the null set is denoted by the symbol like this. If you want to write an example, say A is the set of products like that. X is a prime number less than 1. Prime number less than 1. So there is no prime number less than 1 here. The first prime itself is start with 2. So it does not contain any elements. Or if A is the set of products that prime divisor of 1, it does not have any element in that one. So the null set is denoted by either this set, this or this. Okay. Then other thing is finite set. If a set contains only finite number of elements, we call it a finite set. Example is A. It contains only finite number of elements. Then equality of sets. Equal sets. When we say that two sets are equal, the number of elements should be same and they should be same in them. Suppose if I write A, B, C, D. The set B, D, C, A, B. They are same set. You can see that 4 elements are here also 4 elements are. But only thing is that the order is changed, but these two sets are considered as equal sets. So like that, different types of sets is there. Then next one is subsets. Suppose here is that A is a set like this. We say that a set B is a subset of A. A set B is a subset of A and it is denoted like this. B is a subset of A. This is the notation using for subset. All the elements of B should be an element of A. Then we call B is a subset of A. B is a subset of A when we say all elements of B are the elements of A. Like that, so many subsets we can have here. See, this is a subset of this because this element is here. This is a subset. This is a subset of this one. This is a subset. All the elements of this are here. This is a subset. This is a subset. This is a subset of this one because all the elements of this are also an element of this set. And even I can take a null set also. So the subset definition is when we say A is a subset of B, all the elements of A must be there in B. Here we say A is a subset of B and we can call B as a superset. And See here, always the null set and the set itself will be a subset, considered as a subset. So for these three elements set, how many subsets are there? 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 subsets for the set. And there is a common formula for it. The number of subsets of a given set will be always 2 raised to n, where n denotes the number of elements of the set. So if a set is having 3 elements, then 2 raised to 3, 8 subset will be there. If a set is having 4 elements, then 2 raised to 4, 16 subsets will be there. So that is the formula. Always you must remember, because by remembering that formula you can verify whether you are listing out all the subsets or not. When I give like this, say A, B, C, D, there are 4 elements, and I ask you to write in all the subsets. Then by knowing this formula, you know that there are 16 subsets. So you should have in the answer 16 elements should be there. And the next term is power set. The set of all subset of a given set is called power set. For example, if I take A is equal to 1, 2, 3. What are the subsets for it? The one is null set, other one is singleton set. 1, 2, then 1, 2, then 1, 3, then 2, 3. Then 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8. All these you put in a set symbol. This is called power set of A, and it is denoted by this. Power set. P of A means power set of A. And what is the power set? Set of all subsets of the given sets is called the power set. And then next Venn diagram. Representing a set by a diagram is called Venn diagram. Representation of a set by a diagram. For example, see, I take suppose U is the universal set. Universal set in the sense that is a superset of the given set. Say I have taken A is equal to A, B, C, and B is equal to some B, C, D, something. So I have here A, B, C, D. I put it here. Then A, B, C comes in the one. B, C, D comes in the other. Like that we can represent. It shows that B and C is a common element for both sets. So representing a set by using a diagram, the U could be always a square representation will be there. Inside that two oval shape or so two circular shape will be representing for the set. And this way of representing a set is called the Venn diagram. Representation of a set by a diagram. And then complement of a set, difference of a set. Actually, this portion is this year CBSE has made the deletion of this portion. But along with that, they say that even though the syllabus is deleted, if possible, you should teach them. And why I prefer to give this concept also to you means because you need for building up the next topic or in the next class, this is a must. Difference of sets and the complement of the set. These two portions are deleted from this year. As an examination purpose, directly this may not come, but you should have some idea about this set. Then only the next year when you study in class 12th, it will be helping for you. So for that purpose, I give a little idea about the difference of a set. Okay. Suppose A is equal to 1, 2, 3, 4, and B is equal to 3, 4, 5, 6, 7. Then A minus B, the difference of these two sets is defined like this. From A, remove these elements. So 1, 2, 3, 4. 3, 4 is already in this one. So whatever from the first set, you should remove the elements of the second set. So after removing, what you will be getting? 1, 2, 3 only. Because 3, 4 is there in the second set. And this is called A minus B. And what about B minus A? From B, you remove the elements of it. 3, 4, 5, 6. 3, 4, 5, 6. When you remove the elements here, 1 is not the 2 is. 3 and 4 is to be removed. So you get 5 and 6. This is the difference of two sets. And it is symbolically it will be writing that A minus B is equal to set of all x such that x belongs to A and x is not in B. This is the way the definition will be written. I have shown this is with the help of an example. A and B are there. When you want to find out A minus B, the difference of A and B, that is from A you remove the elements of B. If you want to find out B minus A, from B you remove the elements of A. That is A minus B. So that is the difference of two sets. And one thing I have forgotten in between, that is the operation of the sets. Of two sets. One is union and other one is intersection. These are the two things. Union means, suppose I just take an example and then explain the definition. Say 1, 2, 3, 4 and B is equal to 4, 5, 6. Then A union B is denoted like A union B. This is the symbol using for union. A union B is equal to 1, 2, 3, 4. 4 is there, but you need not write repeatedly 5, 6. That means all the elements of A and B put together is A union B. And the definition of A union B will be writing like this. It is set of all x such that x is in A or x is in B. This is the way we write the definition. All the elements of A and B are to be put together, then we get A union B. Okay. Then next, intersection. Now, same example if I take. From these two sets, 4 is a common element. So A intersection B, here it is 4. The common element is the intersection. For these two sets, which is the common element that comes in intersection. So the definition of A intersection B is like this. Set of all x such that x is in A and x is in B. That you should remember. Here, for union, x is in A or x is in B. For intersection, x is in A and x is in B. So that is the way of finding out this one, union and intersection. This is the operation of two sets, union and intersection. And there are some properties of union. What are the properties? The properties is like that. A union B is equal to B union B. Similar things you have learned in the lower classes. A plus B is equal to B plus A. We call it as a commutative property. The same way, here we say that union. Commutative law. This is called commutative law. A union B is equal to B union A. And the second property is that A union B union C is equal to A union B union C. associative property. So commutative property and associative property is also there. Then A union null set is equal to A. We call it as identity law. A union null set is equal to A. We call it identity law. And the next one is A union A is equal to A. This is we call as idempotent law. So these are the four properties of the union. A similar properties of the intersection is also there. A intersection B is equal to B intersection A. We call the commutativity of intersection. A intersection B intersection C is equal to A intersection B intersection C. This is called the associativity of intersection. And next is A intersection null set is equal to null set. This is the identity. And then A intersection A is equal to A. This is called idempotent law of intersection. So these are some of the properties of this one. And in the Venn diagram, I just want to recollect one more thing. Suppose universal set, this is A and this is B. So A union B represent this full. This is full, this A union B. And this is A and B. Common A intersection B. A intersection B. This is A union B. A intersection B is this shaded portion. Common portion for A and B. So the things can be made very clear by representing the things in the Venn diagram. That is also one of the important use of the Venn diagram. So and one thing I have left over, the complement of a set. That is also not in the syllabus, but it is also better to have some idea about this one. The complement of a set is denoted by like this, A complement. When you want to say the complement, you should have a universal set with you. Suppose A is equal to 1, 2, 3. Okay. And a universal set. A universal set means a superset of this one. Say it is 1, 2, 3, 4, 5. U is the superset and A is the one set. The complement of A is A complement, denoted by this one. So whichever the element is there, remove that element and write the left of the element which is available in the universe. So A complement means from A, whatever the element is A, you remove it and write the rest of the elements in the universal set. So A complement will be written in the simple form, set of all x, that is that x is in U. X is not in A but X is in U. So set of all A complement means set of all elements is not in A. It is not, this element is not in A, but it is there in U. That is the complement of a set. And so this example will give a correct picture. A is a set, U its universal set. A complement means from A you remove A, and what is left over in the complement in the universal set, that should be written in the complement. And there are some two important De Morgan's law. This also is required in the later class. That is why I told the complement will teach learn a little bit. It is the A union B whole complement is equal to A complement intersection B complement. A intersection B whole complement is equal to A complement union B complement. This rule is called the De Morgan's law, and you can verify this result by taking any two sets A and B, and you can verify the result. So even though this difference of two sets and complement of two sets are not there in the syllabus, but better to have an idea for that two concepts. And one more thing which I would like to add is that there are some practical problems one result. If A is a finite set and B is another finite set, the number of A union B, we say n of A union B, number of elements in A union B is always equal to number of elements in A, number of elements in B minus number of elements in A list. That with a picture you can clearly get the clarification of how the result comes. We are not going to write its proof or anything. And then if A, B, C are three sets, the number of elements in A union B union C, this result can be obtained from the first result. Number of elements in A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in A intersection C plus number of elements in A intersection B intersection C. So these two formulas you should remember, because with the help of this we can solve many questions. Just like in our school there are people who likes to play cricket and likes to play football, and some will be likes to play both football and cricket. So this type of problems, then how many will likes to play cricket only, how many will likes to play football only. This type of practical problems can be solved with the help of this formula. I will share the PDF file of it and some questions for it, and complete that work and submit by Monday. Thank you.